Okay, yet another photoelectric effect question, right? Okay, still the basic idea, right, is that the photon energy turns into the work to remove the electron. Okay, plus whatever's left over can be given is the kinetic energy that the photoelectrons could have, right? Okay. Now, we know from the previous problem that our work function is 1.932 or something like that. And then I guess there's a 0 or something like that, right? So from the previous question, we've got this value, right? That's my work function, right? So this photon energy is 1.932 electron volts, right? Plus, and then the stopping potential is 2.6, and now we're being told the kinetic energy, right? If it can go through 2.60 volts and it is an electron, then it has 2.60 electron volts of kinetic energy, right? That's what that means. So the photon energy is, we must add, so plus 2.6, and I get 4.532. Right? So that is my photon energy, but now they want to know what the wavelength would be, right? So now let's find the wavelength. And the wavelength is what, hc over E. This is actually in the data packet just like that, right? Okay, so that is 6.626. And that's joules seconds, right? Speed of light is 3.00 times 10 to the 8th. Right, and then the energy is 4.532, and that's electron volts, right? But we got to put in, we actually have to put joules in for this, right? So I'm going to multiply by 1.602. And that's really joules per electron volt is one way to say what that is, right? All right, so here we go. 6.626 E minus 34 times 3 E8 divided by parentheses. The answer I just got, totally unrounded, right? Okay, times 1.602 E minus 19, right parenthesis. So all I did was I put this denominator in an uber parenthesis. All right, here we go. Are we ready? Chapeau. So I'm getting 2.737 times 10 to the minus 7th meters, right? And that's just fine. You could say 2.737 times 10 to the minus 7th meters. This is ultraviolet light, so I'm going to write it in nanometers. So if I make that 100 times bigger, 274, right, I need to make this 100 times smaller, which is, of course, 274 nanometers. Nanometers.